All right. So there are a couple of topics I wanted to bring up from last week that I changed my mind on. The first one is the difference between a wallet and an address. So addresses are of two types. One is addresses that are derived from verification keys, and other are addresses that are derived from scripts. When an address is derived from a script, then the script's logic controls the outflow of UTXOs from that address. And if an address is controlled by a verification key, that means whoever has the verification key controls the outflow of UTXOs. But on the other hand, a wallet is a third party provided service. It's a user interface where we can create one or more verification key controlled addresses so an individual or an organization can manage multiple of these addresses and the UTXOs in those addresses. Um, do you agree with that definition of a wallet?
Yeah, I guess I'm curious what are you changing from last week? Because that kind of sounds like where we were last week.
No, so last week I was under the impression that wallet is just another name for an address, but now I think it's a third party provided user interface.
Oh, so we
Yeah.
just have the two. We have the verification key hash, and then we have the script controlled.
For
And what you're
addresses.
saying is a wallet is basically a group of the verification key hashes and the logic to switch between those and use them.
Correct.
But it's
Correct.
not a separate thing. It is just a group of the verification key hashes.
So there is more to it. It is surely a group of verification key hashes, but
Yep.
also it's a user interface provided by a third party. And the third party also provides a connection to a node. And that is why we are able to directly connect to the blockchain.
Yeah, yeah, cool, certainly.
Yeah, that is one thing. And the other thing I said last week was that I know that this code right here is the code for a validator because this file ends with an AK. So I've changed my mind about that. Uh, AK, so ICANN is just a language and you can do a lot of it, lot with it, not just write validators. But I know this file is a validator because we literally defined a validator here. It says
Mhm.
validator hello world, and that is why I think this file is a validator file. Um,
Yeah, so you could have different functions or maybe even just a test
a
on a
test or
.ek file
types. Yeah.
or types. Yeah, exactly. So yeah, that's a good correction. It's validator because the function is validator, not because the file type.
Yes, because a validator is defined right here.
Yeah.
Okay. So now jumping into the code, this is where we stopped last week. And then this is the first line from there. It says trace at redeemer string dot from byte array redeemer dot message. So I'm not too sure what this is even trying to say. So it's saying trace the redeemer. Is that how you read it? Trace the redeemer.
Yep. I think, I'm always coming from JavaScript land. So this is how I would do it. And then you know what I mean? That's
Yes.
how it's basically saying the same thing. We're gonna log or traces like logging, so we get the message.
Yeah.
And right here is that first one of redeemer, and then this is like the variable that you could pass in that comes in after the colon. And what
Okay.
the variable is redeemer.message, and again, redeemer is coming from here. And string dot from byte array is like a conversion, kind of like toString in JavaScript.
Mm.
But
So
string dot from byte array converts this variable and just prints it to the console so we can read it.
got it, got it. And we have the message part because redeemer, we defined redeemer as a message, which is a byte array. Um, so, like unspent transaction wrote, this basically translates to the redeemer is this. The message part of the redeemer is this, and this is just think of this as uh, just a string that says redeemer, so that we identify that it is a redeemer. And from byte array, let's quickly look at what from byte array is. I'll go here,
So
and I'm gonna
primitive.
get from byte array. There you go. From byte array. What is this doing? So from byte array is a function that takes in bytes and outputs a string. Okay.
Wait, we have strings?
Yeah, we do have strings.
I thought, but a string is just a byte
Uh,
array?
uh,
Oh, no, no, a
uh,
string is the at symbol. Oh, okay.
so
Actually, this
wait,
is good
isn't a
because
string?
I've been confused about this before. Is really what is a string? Because byte arrays are used all over the place.
No, so I thought
Um,
a string was a byte string. And the core difference between a byte array and a byte string is that a byte array is mutable, as in you can change it up, but a byte string is immutable.
Interesting. Can you trace the string type so we can follow it?
So for that, we'll have to go into primitive types, and I'm going to search for string here. So we have 15 strings. Said differently, you can compare byte strings as a byte string. So they're using byte strings here. So my assumption is a string is the same as a byte string. How can we figure this
But
out?
what's the difference of a byte array and a byte string?
A byte array is mutable. That means you can actually change it up.
That's it. That's the only thing.
Yeah. That is, yeah, that is one of the main things I think.
Okay. On this page, scroll down to where we are in the string. There's the byte array,
So
and that's
it's
when I
it's all saying
understand
byte strings.
as a byte string. Second,
I think this is less again. It's quite common to manipulate base 16 byte strings in a blockchain. So it's shorthand syntax, hexadecimal string.
behind the scenes, Aiken decodes the encoded
Encodes.
string for you and stores only the raw bytes as a byte array. That was what my guess was. I thought we only used byte
Oh,
arrays. This is achieved by prefixing a double quote byte string with a pound symbol.
so this
So
is basically a
that
string
denotes
then.
a string is with the pound, right?
Oh, I
Is that
see,
what
I
it's
see.
saying?
Yeah, that's what I can decodes the encoded string for you and stores only the raw bytes as a byte array. This is achieved by prefixing a double quote byte string with a pound symbol. Oh, so
Uh,
so it makes sense. So they're saying,
What's the
but
difference of these two tests? Note how this is different from.
this so this is the same as this is
Yeah.
the same as this.
Yes.
So these are
All of those.
bytes, right? These are bytes. And this is a byte array.
It's a string
No, so
because
that's
it
a
has the
byte.
pound.
That's a byte string. Okay, okay.
Yeah.
And these are hex encoded. These are hex encoded, I think.
Yeah. It's either hex or UTF-8.
Hmm. So
Base
that's
16. Base 16 encoded.
so are you clear on this?
Oh, only a little bit, but I think we could continue on for right now. It's okay.
Okay. Okay. So we have that. And this from byte array is a function that takes the individual bytes and converts it to a string. So I'm trying to understand what that means. So, so it did take a string and put an at in front of it.
What if we try to trace just the redeemer dot message and not try to do string dot from byte array?
Yeah, I want to see what happens. Yeah.
Right? Maybe that's easier to
Yeah.
help us.
So I'm gonna do this, right?
I would just do no, because that's going to be a property. I would just do the message.
Oh, so you're just saying the redeemer. No, but
Will that work?
so wouldn't it be like redeemer dot message, like with a capital R?
No, because it's this. This is
Oh, it
our
is this one.
variable.
Yeah, yeah, yeah. So redeemer is the type. Okay. Yeah, yeah.
Yeah, exactly.
So let me do a quick,
Yeah,
I can
try.
check.
It's okay. We're just not using it.
It
So
doesn't.
look, it's with traces, redeemer H, and then that byte array.
Yeah. So why did we do the dot byte array then? Like if this is passing either way.
Well, now here, run it again. I just changed it back. So run A can
Let me
check again.
quickly see. Okay. So with traces, oh, so it's actually showing the string here. It's saying hello world, but in the previous one, it literally had the byte array,
Can
right?
we take this information and go back to the docs and understand it now?
Yeah. It says H. Do you have any idea what the H is?
That's like an identifier. I think we could just skip it for right now. The meat is inside of the quotes. That's what we're converting.
Okay, okay. So let's
I
go to
think.
the.
It's a little hazy for me. Those right that H. I don't know. I've seen that before though in other aching code. Um, so what
So we
wait,
ended up
go,
with this
we ended up
guy.
with that exactly.
And when we
Um,
didn't do this part from byte array, what we got was this one. Just
wait,
this without the pound.
go back to the other.
The this one. So we have hello world here
Oh no,
and
sorry, the other docs.
the other docs. Okay.
Yeah. Right, because what we're saying is we have a string. That's what we're using.
Mm-hmm.
Or no. What right? What are we is our redeemer dot message a string to
It's
start
a
and we're
byte array. No,
converting
it's a
it
byte array.
to a string. You're
Yeah.
right.
Yeah. So,
That's right. So it's like a saying a new string from the byte array that I already have.
oh, okay. So it just becomes like a human readable format by the end of the day, but it doesn't
That is
affect the code itself.
correct. Yeah. Because right, those equal statements that we're looking at in the other docs, right? They're
Uh-huh.
all equal, saying that like it's just another way to say it. You could either display it in the the hex encoded one or whatever you call it, or you could decode it. Um, yeah, that's kind of how I'm thinking about it.
Okay, okay. So what do you think is the reason for this line in the first place? It's literally saying, hey, the redeemer is this, right? So what happens if we don't even like say this?
Oh, well, nothing, right? That's just helping us understand what it is. But I think why is it doing that? Because let's look at line 36. Let must say hello equals redeemer.message equals hello world.
Oh, okay,
So
okay.
what's interesting is this is actually really good. And this comes back to the docs because it doesn't matter what, like, we don't need to convert it from a byte array to do the equals, right? When we do this comparison,
Mm-hmm.
this could be in that string format, right?
Yep. Mm-hmm.
And because when you convert this, right, or whatever, it it converts. That's what we were seeing. So when we trace that, we're showing the conversion of it, which is human readable.
I see, I see.
But
So, yeah.
but the point is, like, we don't have to do this. This
Yeah,
is my
so we
point
don't
I'm
even
trying to
need
make.
this line. We are just doing this line so that we understand what the redeemer is here.
And we can read it, yeah. And so do you
Okay.
see this? Like, I think this would also work.
Yeah, let's check it out.
Okay, yeah, run it.
And did you put the array correctly? Oh no, no, it should work. 1 second. Um,
Ah, good. It didn't work.
but why didn't it work?
Okay. Well, what I changed was I changed string dot
String.
from byte array. I'm referring to the following type of string, but I found an expression with a different type.
Oh, but you did convert the byte array to the string here, no?
Yeah, well, and that's the problem. The original code doesn't do that. So I guess, right, the question is, why are we doing the trace message? Okay,
Yeah.
because this is human readable. This is not human readable, but
Mm-hmm.
used in the comparison. Right?
Yeah.
We use it to compare. Um, and if we
So this
want,
is a byte array, right?
yep, because
But
it's
this
coming
is a
from,
string, and it
no,
doesn't have a
no,
problem with
it's
that.
not a string. This would be a string.
Oh, I
This
see, I
is a byte
see.
array.
Oh, so both are byte arrays. Okay, 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 okay. Got it, got it. Oh,
Oh, okay, cool. So
uh-huh.
let's do this then. Let's convert both of these into strings.
Okay. So maybe they'll just put a pound here, right?
Yeah, try that. Yeah, I like that.
Okay,
Right?
let's
Let's see
try
that.
that. Yeah, so this is a string and now this is a string. So let's try that. Huh. Am I
All right.
getting something wrong with how we are
Oh,
defining
let's do the
strings?
at symbol. Maybe it's this. This is what we're trying to figure out. So Rania can check again.
Yeah. What
I
did you
know,
put?
because
Let
that's
me
the
quickly
pound, but the
see.
other thing you said at.
Oh, at,
So
okay.
I don't know. Let's just try at.
Oh, that worked. Oh,
Okay, so what we know at this point is the at denotes this string.
I see. Okay. So the
Can
I
we
think that's a good thing to like put in comments. I'm gonna put that.
let's make these tests actually work.
At is a string literal, not a is a string. Okay. These tests work as in they work, no? All of them work, no?
Well, I want the fails to be passes. So I just fixed the first one, and hello
Oh,
world became
so the first one
true.
is suppose. Oh, you fixed the first one. Okay.
I did.
Let
What's
me.
the second one? What's
The
the error?
second one is the same. I just changed the message. because these both are the same ones. We want the first one to fail.
Oh, you do?
Yeah, that because this one, example one and example two are the same with like a different message. Yeah, so and we can change it to wrong message. Yeah.
Okay, now we're on Aiken check.
All right.
All right, we want that second one to to pass though. So
So this
why is
redeem
that one failing? Must be signed as false.
yeah, must be signed.
Oh, I see why. Do you see why?
No. So this one, the second one is failing, right?
Yeah,
So
but the
must,
third one is passing.
yes. Message. Oh,
Right. The error is not the right signature, right? So what does that tell you?
it's
Must
not
be
the
signed,
right signature.
or it must be signed as false. So we're missing a signature.
Where are we missing a signature? So the first one passed, right? Because it's supposed to fail. Okay, that's fine. So the second one
Because it's
should.
yeah.
Uh,
It's actually I would go look at example number 3 because that one's actually passing.
uh, oh, because of this one.
Mm-hmm.
So extra signatories is datum owner. What does that mean? Does it mean it is expected to be signed by a specific verification key hash?
This is the owner.
Let datum. Oh, so we have put the owners. Wait, so we actually put the verification key of the owner in the datum in this one?
The public key.
Oh, the public key. Okay, okay.
Or
Oh,
maybe maybe it is. It is. I think it is the verification key hash. We could check that, but because so list that has self.exe signatures.
so this is byte.
Oh, here it
Mm-hmm.
the we were just asking like what is this, and
Mm-hmm.
I think that's not the right question to ask right now. The question
Yeah, yeah,
is,
yeah. Mm-hmm.
does this datum see how it
Uh-huh.
gets passed in here
Mm-hmm.
with this owner gets passed in here? It also gets passed as extra signatories because what you're going to need is you need the extra signatories to match the datum. If we scroll up into the actual validator,
Yeah.
right, extra signatories
Must be
needs to
signed
match.
list dot has.
Yeah, so we could go into that, but basically these are our two datas. We have our extra signatories, and we have our datum dot owner, and
Oh, so
so
we are comparing them, like we are
so they
saying,
need to be the same. Like if
mm,
we wanted this test to fail, we could pass a datum owner different than the signatory owner.
oh, I see, I see.
Does that make sense?
So, so if we, so my understanding is that the owner has a verification key hash here, right? So
Yes.
depending on if we pass the verification key hash in the datum as like so whoever verification key hash is here, they have to sign this for this to pass.
Yeah, that's
That's all
exactly
it
what
is
it said.
saying, right?
Yeah.
So yeah, so okay, now I get it because the self is just whoever is signing in this specific case.
Self is a transaction itself. And then the self dot extra signatories,
Uh-huh.
that is
That
That's
is
who is
the
signing.
that is who is signing. Okay,
Yeah,
okay,
extra signatories. Yeah.
okay. I think I kind of get it. So first we are making sure that the message inside of the redeemer is exactly equal to hello world.
Hmm.
And then we are saying the person who signs, their signature should match with the signature that was passed in the datum. And that is when the hello world passes. Like this transaction will go through.
So when in the flow of the blockchain, like when did the datum get set, and why does right? How do you match the signature with the datum? Can you explain that? Is it all in one transaction? Does this happen, or is this in two?
It's all one transaction, I would think.
You create the datum in at the same transaction that you try to spend it.
I would think so because there's only one self, right? Which is one transaction.
But when do you create datum? When you put it into a validator, or when you spend it out of a validator?
Um, the datum is already in a UTXO, and I'm just trying to spend that UTXO. And to spend that specific UTXO, my signature should match with the signature mentioned in the datum.
Yes, exactly. But when did the datum happen?
Oh, the datum happened beforehand. Unless there is a UTXO,
Before.
there's nothing to spend in the wallet.
Yeah, no, that's what I wanted you to say. Was it was before. So
Yeah,
somebody put a UTXO at the Hello World validator, and
correct.
when they put it there, they put that datum dot owner,
Correct, correct. Okay, so they're, yeah, yeah, that makes sense. They are already
and then it,
saying, hey, this UTXO can only be spent by this owner, and they also have to say hello world in their redeemer.
so yes, but again, it's two separate things, because like let's say I put the UTXO in there, and
Mm-hmm.
I put the verification key hash in the datum
Mm-hmm.
as yours, as your
Mm-hmm.
verification key hash.
Correct. Yeah.
Okay, so I put it there and I put the datum on there. Now it's sitting there at the validator waiting to be spent. You are going to try to spend it. Your
Correct.
redeemer needs to match the datum that I put there.
No, my redeemer needs to match the hello world, but my signature needs to match the datum.
Your redeemer
Needs
needs
to
to
have.
match the hello world,
Mm-hmm.
correct? And the signature needs, you said that absolutely correct. And I said it wrong initially. So, yes, you're right.
Okay, so I think we are pretty clear with this, but before we move on to the tests, I want to just check the list.has. What is this doing? I mean, this
Yeah.
almost
And then the
seems like
last line, too. We want 39 and 40, I would say.
yes, yes, that's right. So this is, I mean, just from reading, I don't even know what this function is. Just from reading
List.has.
this, it says this list
Mhm.
has a signature that is corresponding to a specific owner. Okay, that part
Yeah.
confused me. So I'm going to check list.has here. Dot has. Okay, maybe I should say list.has. List.has. There you go. So has is a function that takes a list and a specific element and gives a bool. That means it is checking if a specific element exists in a list. So for example, list.has, the list is 1, 2, 3, and then the specific element is 2. And if the 2 exists in the list, it gives true. And if it doesn't, it gives false. Okay, that makes sense. So it is saying this list has like the signature of the specific owner. So what
So,
is
yeah,
user
it's
here?
looking for the owner. That's what we're trying to find inside of the list
Oh,
of
there you
extra
see.
signatures.
So it is in datum. Oh, so when you say owner, it is the verification key hash. Okay, okay. So you're basically checking if this list has the verification key hash we were looking for. And where are we getting this list from?
So the list is self.extra signatories. That's the array. If you look back at the code, the
Oh,
first parameter is the list, and then
okay.
the second parameter is the find. But it's right
Uh,
there.
so here you go. In a transaction, all the
Oh yeah.
signatories are passed as a list. And
Yes.
if this list has the correct verification key hash, then this will be true. And if it
Yeah.
doesn't, it'll be a false. And in the end, you are saying must say hello and must be signed. So must say hello is a variable that actually is either true or false because we are comparing this string dot from bytes redeemer message is equal to hello world, and must be signed is again a bool because list dot has gives out a bool. And then we are checking. Yeah, so must say hello question mark just means is it true, right? How do you read this question
Yeah.
mark part? Because this is
So
already hello, so what if we remove the question marks? Yeah,
this is easier to read because this is the actual logic. It's
correct.
like this is a boolean, this is a boolean, and so what you're saying is boolean and boolean, which itself resolves into a boolean of either
Yeah,
true or
so
false.
true and true is true, true and false is false, false and false is false. So yeah,
Exactly.
so both of them
So
must be true for it to pass.
you could do something like if you wanted to print this statement, you're right, because maybe you're debugging and like you think this should be true, but you like the whole thing is failing. So but you don't know why. Is it this one or is it this one? You want to come in here and trace and figure out what things are doing.
Ah, okay. So you're
And so
literally
you could
using
write,
trace as a console log, console.log pretty much.
yep, but instead of writing this line here, if you just add the question mark, it'll do it for you.
Oh, I see, I see.
Right?
So,
So that
mhm.
logs it, which is really handy because then you don't have to write the trace statement. You can just, but then you get all the traces at the end.
I see. Is the question mark? Okay, so I'm going to write that down as a comment. Question mark is a boolean that returns um, marks logs the result
I would say
of.
traces. That's the more accurate because they
So
don't call it logs. I call it
traces
logs because I come from JavaScript, but they call it trace.
results of the. So are you saying without the question mark it wouldn't like log the results or trace the
Yes.
results?
Yeah, you could. We can test that if you want
Yeah, I'm just checking. So where like
with traces. That's where we're getting it. So see how it says must say hello equals false on that first one?
first one must say hello. Oh, yeah, yeah, yeah. But isn't this the test? I think this is the test. This is not
Let's
being
see.
logged because the test says
No, it doesn't.
no, it doesn't.
Yeah, it's remove the question mark of must
Yeah,
wherever it's failing. Remove both of them, I guess.
yeah. I'm gonna take these off and I'm gonna
And
try
then
it
that
one.
that third trace statement of the first function
Yeah, I'm going
will
to
not be there.
let's see. That's right. You're right. It doesn't say so. The
So
difference is
yeah,
in the
maybe let's
previous
remove
one,
these.
must be signed is false, must say hello is false. So this is not showing up if we do not put the question marks.
Here,
Okay.
run it again.
So what did you change?
Just run it.
Uh,
Okay, I removed the other trace statement, so it's easier to figure out what we're
Ah, I
talking
see, I
about.
see. Okay. So the question mark literally shows up as a trace that show up in your tests.
Yeah, like
Okay.
a named trace. It like tells us what variable is failing. So it's just a shorthand instead of writing that whole statement.
I see, I see. So in that case, yeah, so in this case, instead of trace at redeemer, can we say redeemer question mark? And this, no, right? I don't think that's how it works.
I
Like,
think you would need the variable like and again this is like the final Boolean statement. So like I'm returning the Boolean value of this, like is owner true or false. So I think this would work, right? You use the owner there and then you add the question mark.
yeah, yeah, yeah. Yeah. So, and also, can we write like, say, for example, you wrote owner question mark, right? Uh, s- so you can you write like these question marks in between the validator logic, or would that would the validator think, hey, I need to stop here because there's a bool there?
I don't know. We could probably test that. I think I've only really seen it at the end.
Yeah, me too.
Um, but how could we test that? We could
We
do
could literally do that, owner question mark, and see what happens.
okay.
Okay, so I'm gonna test
I think
that.
it's going to skip all this. I think it's just going to return the owner. So it's going to return true.
Okay, let's see. So it says expected type bool. Oh, here it's not a bool in
This
the
is not a
first
bool.
place. It's not even a bool. Yeah.
Uh, let is a bool,
Okay.
and then is a bool.
Wait a minute. So owner
Is the
owner is just a
verification key.
verification key hash, and you just gave it like a variable, and you're putting a question mark, which is the same as owner dot question mark. I don't think that would.
Yeah, I agree. I think you're right. At the same, this is kind of just how my brain works of how I debug things. I'm like, oh well, does this work? Um, so will you try it? I think you're right. I
Yeah,
don't think it's going
let's
to
try
solve it.
anyway. Like nothing to lose. Yeah.
Yeah.
It's ex
Okay. So how do we get it to right? What we're trying to do is figure out what this question like.
so yeah, the question mark. I don't think the question mark works like it works in TypeScript or JavaScript. Like, if a variable exists, like the question mark literally makes it a bool, right? In TypeScript or JavaScript.
No, no,
Yeah. No?
no. The yeah, no. You could like this makes it a bool in JavaScript,
Oh,
but the question marks that's not a syntax.
really? Oh,
I don't think so. I mean,
exclamation mark.
the exclamation mark. Yeah, yeah, yeah. The double bang
Oh,
makes
that's a double. Okay, okay. Yeah. So,
like
yeah. Hmm.
in JavaScript, right? This string with the double bang equals true
Mm.
because this is truthy, and then the double bang makes it a actual truth. Anyways,
Yeah.
JavaScript is fucking weird.
Okay, so this we cannot put a question mark in front of but like say for example, so these are both bools.
So what if we do
So yeah, I want to see what happens. Like, will it even get to this one or will it just stop here? Is my question.
Yeah, exactly. That's the question. And the side part of this question is, does the question mark change this? Implicitly discarded. I found
Yes,
a discarded expression not bound to a variable.
interesting. So, 1 minute, let me try one thing. So, my understanding is if there is logic here, then this won't pass. So, let me try it one more time.
I think we have to save it. Or it worked.
Uh, Here's the
It
warning,
worked.
that's fine. So, yeah, I think it worked.
Yeah, scroll up and see the passes.
Yeah. So,
Okay,
this worked.
so it failed when you had logic beneath that. So that
Correct.
is a final thing. It's and
Hmm.
I think it has nothing to do with the question mark. Like if you remove the question mark and then add those bottom lines back in, it would fail again. Like the question mark is just the trace
Is
statement.
yeah. So a validator always has to end with a true or false. So you cannot have a random true or false in between.
Yeah, I guess yeah, it's interesting because I could also see it. I mean, I think this is a Aiken specific thing that they decided to do is in that case that we just came up with, it just fails because it's not. I mean, I guess I'm not sure why it doesn't return a Boolean and just skip that stuff. But again, my mind comes from JavaScript where the whole thing is different. It compiles different. The functions run different. So um, yeah, interesting, right? And one of the things with Aiken is like they make it so things fail when you want it to fail. Um, it's like it's stricter. There's more guards, and
Correct.
which is a good thing. That's what we want. So
Yeah. Otherwise, like the compute fee goes higher and higher.
mhm.
So yeah, they make sure that it has to fail. Okay. Okay. So that is pretty good. I feel pretty good about this. Uh, and I'm going to remove this guy. And I'm going to put oh, and I'm going to put one more comment. A validator always ends with a boo. Okay. So I feel pretty good here, and I also understand the logic of this tiny validator. Um,
Yeah, we covered a lot. We covered datums, the redeemers, why is it optional, how to get the variables from those, a little bit about comparing things, about when data gets set in datum, and then
mhm,
how to compare that when you're spending it with the
mhm.
redeemer, right? Because I
Yes,
think that's a big um, understanding gap to initially get into this is like how do you transfer data back and forth,
correct.
and right when you put a UTXO add a validator, you
Mhm,
add the datum at that point, and then it's at the validator chilling with its datum, and then
mhm.
somebody comes and tries to spend it, and you spend it with a redeemer.
Correct. Yes.
Yeah. And then
Yes.
you have this environment where you have a redeemer passed in from the spender, you have the datum passed in by whoever locked it, and you
Mhm.
have all of this information in an environment where you can perform logic gates on it.
Correct. Yep.
Yeah,
That
and right.
makes
So our example here is we're using the redeemer's message, and we're using the datum's owner as just examples of like using pieces from these 2 points and performing some sort of logic gate. So it's like, yeah, this is all it's saying is hello, but a lot of the fundamental Aiken stuff is right here.
Yep, yep. I agree. I agree. And one more thing. So you see an else fail here after the main logic. in the spend.
Yeah.
And this else fail, as far as I understand, is literally just saying, hey, the the script purpose only has to be a spend. Otherwise it fails. No other script purpose is allowed. That's my understanding of this else fail.
Yeah, because you could have different things on this. You could also have a mint. You can have a withdraw,
Withdraw.
and there's a whole bunch of them that we've looked at in the docs a bunch. But yeah, so
Yes.
instead of writing like mint is null or whatever, mint fails, you can just catch all with this.
Yes.
And so
Yes.
all we have is the spend.
Correct. Yes. Okay. So I feel pretty good to move on to the tests.
All right.
All right. Okay. So now that we understand the logic of the validator, let's move to the tests. And for the tests, any test that we are doing always starts with the name of the test. Sorry, starts with the keyword test and then the name of the test. And the test is a function, so you have these two brackets here, the round brackets, and in the flower brackets you have exactly the test. So let's see what this test is saying. This test is saying, let datum, you're assigning the datum and you're giving it an owner, so that means this is a verification key hash. And how do I know this is a verification key hash? Because we defined the datum as a verification key hash. And here you are saying, hey, this owner part of the datum is a verification key hash. You don't even have to say owner. Say, for example, I say something like player, which doesn't exist in what is expected. My understanding is that this test will fail because of this.
Yes, I agree, but it's the wrong one because this actually is a failing test.
Oh, you're right.
So,
So it'll, yeah, that's right.
but yeah.
Yeah. And the reason this is a failing test is because the name of this test starts with a fail right here, fail underscore, and then the name of the test. Yeah. But if you say success or anything else, or if you don't even use the word success, oh, what was that? Uh-oh. And if, yeah, you could use any other name as long as it doesn't start with fail underscore. Uh, this is meant to succeed. That's how the test understands it. Okay. So we said the datum has an owner and we gave it a verification hash. And then we are saying the redeemer has a message called the hello world. And we are also saying there's a placeholder UTXO, which is the output reference. And why are we giving this output reference? Because in the spend, you have to give all of these guys. For the test to even start, you have to make sure that all of these values are given to it. And that is what we are doing. So first we are giving it a datum, we are giving it a redeemer, we are giving it a placeholder UTXO, which is the output reference. And the output reference has a transaction ID and an output index. And then we are calling the hello world dot spend. So the validator name is hello world. And when you want the validator to be called, you say hello world dot spend, like you see in the test. Hello world dot spend, and you pass in all the things that we defined right here: datum, redeemer, reference UTXO, and the transaction dot placeholder. Where did we get transaction dot placeholder from? Let me see where we got that from. Uh, Cardano transaction. Where did we get the placeholder from? Do you have any idea? Unspent? This placeholder?
Mm,
Mm, Transaction. So I think we got the transaction from Cardano slash transaction. So I'm going to quickly check. Uh, so in this guy, we have
I think it's
Cardano
because
here.
we're not actually using the transaction, so it's just doing a right? It's just a filler. It allows you to continue without thinking about it.
I mean, like, but placeholder. Oh, see here. Yeah, placeholder is a type of transaction. Placeholder slash empty transaction to serve as a base in transaction builder. This is particularly useful for constructing test transactions. Every field is empty or null, and we have in particular transaction.placeholder.id is this. Okay, so when you are saying transaction.placeholder, that means all of these sections in the transactions are empty or null. Okay, and it is
Cool.
predefined. So when you
And so
call,
where's our placeholder? Do we have a placeholder in that?
we do have
No.
a placeholder. No, not in this, like, but
Yeah.
we do have a placeholder,
The
transaction.placeholder.
placeholder is that.
Yeah, it's just an empty
Because that
transaction.
has a placeholder dot ID. Does our transaction have a dot ID? Do you know
So
what I'm
that,
asking?
yeah, so the transaction literally has all of these things.
Yes. Okay. So we could have called placeholder dot certificates.
Yes, we
Okay.
can call placeholder.certificates. You can call all of them, but it'll only be either null or none or one of those
Yes.
things, one of
Yeah.
those
Yeah.
empty things. Okay, so I think I understand. So as long as you bring in the transaction from Cardano slash transactions, you can use the placeholder part of the transactions. It comes with the transaction right here. And that is how they
That's the
used
type.
transaction dot. Uh-huh. What
Yeah.
was
You
that?
kind of, that was the type. And I don't actually fully understand what we're bringing in here. Is transaction just available, or do we really need that import statement? Because how I
We
read
need the
that
import
imports,
statement. Say, for example, I'm going to remove this. Okay. Now you won't be able to do this. I'm
no,
going
because that
to.
was the type. That was the type, man. You're missing it. It's okay, but
Oh, that's the type.
yeah,
Oh, you're right. If that is the type, then
that's what I'm saying. There's like it's the lowercase transaction that it's looking for, but the syntax you use at the top, I feel like is only bringing in the two in the curly brackets. Is not bringing in the whole Cardano slash transaction.
correct. You're right. You're right. This is only bringing in the types. So what unspent is referring to is, so
It
these
could
are
be.
all types. You see the types here. All of these are types. So what I was showing you is a type. Transactions type is defined like this. That means it has this data structure inside of it. But here we are actually like calling a transaction. You see the small letter here, the small t here. That means we are actually bringing in a transaction. So what I would think is, since self is defined as transaction here, I would think it could be self dot placeholder as well, right? Or does it have to be transaction?
I think, and I don't know, but I think we just have access to a transaction, and so we can just call it.
Oh, you
Um,
think so? Oh, okay.
and maybe it comes from that import statement, but maybe you can just call it, and it's just available to us. It's like a built-in. Um,
Mm,
but it's kind of hard to test because we need the type of transaction and we need the type of output reference. So it's like I don't even know how to run the test if we actually, yeah, this is the goal. Let's try to run a test.
yeah, let's try to
Uh,
run a test. So
can I do
you,
this as something else if we don't bring in the transaction? You're not following.
no, no. So what was the question? So you removed the
I'm on
types
line
here.
30. I'm on line 30.
30. Okay.
If we don't bring this transaction type in, because basically I want to, I just want to make it true.
Okay.
Um, and I don't want to bring in this transaction. type.
So,
Because
I
I
mean,
don't
we
want
will
this.
run this test either way, but my question is, in the spend itself, all it is expecting is types. It's not expecting any real values. It's just expecting all the types anyway. So without bringing in a type, I don't know how we would even pass the self. Oh, you're
That's the
saying,
problem. That's the problem. I'm trying to do it without that, but I agree. We need that.
okay, let's try it
So
anyway. No, so
it's
just for example, I want to see what it would say.
it's going to say transactions not defined.
No, it stops just before that.
Output reference. Yeah. Okay. So I don't know how else. Right. I mean, maybe what we're saying is who cares? Because in all of the validators, you're going to be pulling in these types. You're always going to be using the output reference and you're always going to be using the transaction. So whether that placeholder comes from this statement or it's literally just a built-in and you just always have it. I don't know, but I think maybe it doesn't even matter because every file is always going to have this because you need output reference and you need the transaction. So whether
Mm-hmm.
that comes with it or whether it's built in anyways, who cares? The point is, or what we're learning is we have access to this transaction dot placeholder. So
Okay. So what if I just like change it to self? I want to see if that is a thing.
it'll fail, but it's a good question of why.
Let's see. Self unknown module. So yes, you're right. So transaction is a built-in that it
It's been
naturally
imported.
knows.
Yeah, it's a
It,
special thing.
it hasn't been imported because, like you said, we only imported the type here, but the transaction itself,
Well, yeah, I mean, how it was imported, we don't know, but we have access to it, so it has been imported, right?
yeah, that's right.
I think, yeah, I think it could be. The thing is, like the import statement, my fundamental understanding is if you want the whole thing, then you don't do the curly brackets at the end. You just use Cardano transaction. Um,
What are you referring to? What curly brackets are you referring to?
line 4 at the very top. Maybe this is what we need to figure out. Like, what is line 4 actually saying? Are we bringing in the whole package of Cardano transaction, or are we only bringing in those two types of
We are
output
only
reference?
bringing in these two types, as far as I understand.
But I think what we've just discovered is the opposite because we have this transaction, right? We have the transaction dot placeholder. So
But like constants. Oh, 'cause there's a constant called placeholder. There's a constant called
oh
placeholder.
yeah, what is this?
So this is the same thing as this.
What is constants? It's the only one in that group, right?
Yeah, it is the only one in that group.
So constant again, it's like where is this coming from? And maybe it doesn't matter, okay? But like constant to me kind of sounds like it's just constantly there. Like we
Yeah,
just
it is
always have access
constantly.
to it.
Yeah. No, that's what it
And
feels like, right? It's an empty transaction.
that we
But
just
it's
always have
that we just always have. But why did we call it a transaction dot placeholder? And we didn't get the placeholder here.
because placeholder is a property of the object transaction.
And where did we get the transaction object
I
from?
think it's from use Cardano slash transaction.
Oh, so we are invisibly bringing in a transaction object as well here, is what you're saying.
I think, yeah, at this point, and again, I would have, yesterday I would have been exactly where you are, thinking that we're only bringing in those two. But at this point, I think we're bringing in the full use Cardano transaction and we're bringing in those two types. Or this constant thing is just available. It's just always available.
Mm.
How can we test this? We need to get, the thing is you can't. You can't. It's what we were already saying. You always need
Yeah.
output, you always need the transaction. So you can't even do a validator without
Yeah,
this.
we can't even like comment this out and test it because we get stopped right here.
Yeah. So again, I think the answer is it doesn't matter. Right? We just have it.
Yeah, we just have something called as a placeholder, which is a constant that comes from the transaction, but we don't necessarily have to import it, we just have it. Okay, well, I'm
It
going to put a comment here because I don't think I'll remember that. The mm, dot is a placeholder for transaction, and also it is automatically imported without specifically.
we can't accurately say that though.
We can't accurately say that.
Right? We just have guesses at this point. We don't
Yeah,
know.
I'm gonna say yes.
Yeah.
Yeah. Okay. Okay, now we understand this part. I feel pretty good. I mean, now that we guessed this part, if not understand, maybe someone else will come and tell us otherwise one day. Um, but I feel pretty good about this. The output reference, transaction ID, output index. So this is an empty transaction ID, and the output index is 0. Oh, placeholder UTXO. So I'm guessing this is a So I'm guessing this is also a part of the placeholder transaction. See this?
I think, yeah, honestly, I'm looking at my other code right now and my other
Uh-huh.
tests that don't
Mm-hmm.
use placeholders.
Uh-huh.
And it makes a lot more sense, like looking at my code.
Oh,
I
oh,
think like
oh. Uh-huh.
this is just such a boiled down example. Um,
Uh-huh.
that yeah, I don't know. It's just because like the transaction dot placeholder, like that's where the logic is. That's where you actually build your transaction.
Correct.
Um, and right. So I think in this, what we're talking about here in this boiled down version, I really think is uh this data transfer logic of between the redeemer and the datum. And I think that's the whole point of this example is to understand how a redeemer gets its data, how a redeemer gets its data, and then how do we use those two pieces of data to construct some sort of logic.
Correct.
And this is skipping everything else that is important.
Yeah.
So what I read here is remember we were talking about like how does the datum get added? Well, that is in the first transaction when it gets locked. And then when does the redeemer get added? That's in the second transaction that's actually spending what was previously locked there.
Yeah,
And
that is
so
the yeah, correct.
so our test right here is trying to do that second stage where we're actually trying to spend it.
Correct.
Um,
Because
but
sending in UTXOs is not controlled by anyone. Like anyone can send in a
yes,
UTXO with any datum.
yeah, there is no logic gates for that. So we're trying to simulate this second step, but we also need to simulate the first step of setting that datum. And this is confusing to me when I was first learning it because the test it just fundamentally works differently because of this of what we're saying. You can't prevent the sending. So you're kind of just simulating it with this datum. So the way I read this is like step one locking value locking value, right? And that gets your datum. And so step two is
Unlocking value.
trying to spend slash unlock value. Okay. So we're like assuming this has already happened and it's already on chain. And so what we would do when we're creating a transaction to actually spend it is we're going to find that datum on chain. And
Hmm.
now that doesn't exist. And so we just use this hard coded value. But like really, this here would be like, you know, look on chain, uh, get datum, use data, right? Like you would find all that and then you would put that datum here to try to spend
Correct.
it. Okay.
Correct.
But,
Correct.
okay.
And also as far as like these random, say for example, we are trying to unlock this specific UTXO, right? This output reference. Um, but we could also have logic in the validator that says you can only spend UTXOs that have a specific datum. So some random person that sends some random UTXO with or without datum that doesn't match what we want can be locked forever. That means that that UTXO can never be spent.
Yeah, I think that's a great yeah, so right, like if the validator right now expects datum with owner of type verification key hash.
Hmm.
So if you were to send a datum of type dog,
Yeah,
it
that is
would
locked forever.
it
That
will be
means
locked forever because upon spending it, you're requiring the datum to be of type owner. So if somebody
exactly
put a datum in there of dog, it's it will never pass this check and therefore it will never be spendable. It will be locked forever.
correct. Yes, yes, that makes sense. I am going to get these. Yeah.
Yeah, let's get it back into
All right. Okay, so I understood this hello world example. Oh, wait, this hello world example would still fail.
oh yeah, well we're still in the test. So
Would it fail? Because we have the owner, but we don't have the
it would fail because we don't have the
signatories.
transaction.
Yeah. No, wait, what happened? Like, did this pass or fail? This should fail, right?
Do a can check because I wrote a new test since we've done this last. We
Yeah.
want test one to pass, but I think it's going to fail because we don't actually have the transaction.
Self.
Uh, I know what I did. I changed it to underscore self. Okay, try again.
Okay. Self dot plus. Oh, wait, oh, this has to be transaction dot placeholder. Okay. So we have transaction dot placeholder. But either way, both hello world example one with hello world and wrong message both should fail because
They
no
don't have
one's
the
we are not checking the
redeemers.
signatures.
Yes, they have redeemers, but they don't have the signatures.
Something passed.
That's because it should fail. Let's look at
Oh, I
the
see, I
first
see.
one.
Okay.
Let's look at the first one because
Yeah,
that one
this is
failed.
the first one. Yeah. So in the first one, we are making sure the datum is something, the redeemer is something. This is the redeemer is the right redeemer. The placeholder UTXO is also some empty placeholder UTXO. And we are calling hello world with some datum, redeemer, placeholder, and transaction as a placeholder. And it fails. And it fails right here.
Must say
Say it's a
hello is
must say
false.
hello is false. Wait a minute. Why does it
Oh, I
say
know
must?
why. Look at the redeemer. It's the it's missing.
Uh,
No, it's missing a exclamation mark
Missing an
on
what does
hello
that mean?
world. It should be hello world exclamation
Oh,
mark.
hello. Oh, I see. I see. I see. That's what. Okay. Okay. Got it.
Okay,
Yeah.
yeah, run it
Okay.
again
Yeah. Um, I mean, I think it should fail still.
because of a different reason though, right?
Yeah,
Yeah, it
it
must
should
be
fail
signed
because
as
there's no
false.
signatories. That means there is no way to compare like the signature. So this part is correct. This part is correct. But yeah, if you put that, then I think it should pass. Yeah, this should pass. Transaction dot dot transaction placeholder is saying
Spread.
in the placeholder, forget about everything else except the extra signatories part in the transaction.
This is like
Uh,
spread operator, right?
yes,
It's like spreading in all of the placeholder, but then overriding the extra signatures.
correct. And now I think it should pass. Let me try it.
I think so too.
Oh, there you go. It passed.
Sweet.
Okay, I
Right.
think now I understand. So this is still like a little. So in the transaction body. So can you explain the spread operator to me? What exactly does that mean in English?
It would be like let A equals 7 down 2, and then let B equals A and fish of 3. So again, JavaScript. But what you would do is you define an object
Mm-hmm.
here,
Mm-hmm.
and then if you wanted another object to like inherit all of these properties, you
Mm-hmm.
could spread that object in. So what this is
Oh,
saying is like, it'd be the same as this.
oh, I see, I see, I see. That's what it's saying. But
We're
but this
taking
is
the
that's not
A
what's
object.
happening here though, right? Because we are saying in the transaction there is the rest of the placeholder stuff, but in the extra signatories exists in the empty placeholder as well. Oh no, it doesn't.
Oh,
Because the
you know what
empty
this is?
placeholder, uh-huh.
This is yeah, it's like an Aiken thing. It's like do you know the pattern of destructuring?
Yeah, we kind of discussed it last time. Yeah.
Yeah, so it's destructuring. No, wait.
No,
Because
but
what
I
you
think
said is this is like they exist, but we don't actually care about them.
yes, yes, that's what
Um,
I'm thinking it is.
but I don't know because normally I'm in the validator environment. This is not the validator environment. We are in a transaction builder. Because
Yeah.
normally the structuring looks like this. You would do like whatever, some variable here. And you would expect the transaction to destructure out of
Yeah.
this variable, right? But we're not doing that. This
Yeah, no,
is
no, but the spread operator makes perfect sense to me because we are saying, hey, in the transaction placeholder, everything is empty, but we are assigning the extra signatories part to datum.owner,
but
you
if you were
know?
to do this, oops, you're not going to have all of those extra transaction properties, right?
Correct, correct. So the spread operator is makes perfect sense to me in this case.
Okay.
Yeah. And now we are just saying in everything else is empty in the placeholder transaction.placeholder except the extra signatories part where you are assigning it the datum.owner, which is
Yeah.
this. And that is why this passes.
And again, when we're building more complicated examples, we're going to use a different syntax here that I think is going to make this a lot more declarative.
I
because
mean,
we're going
but
to actually be building all these things, right? You need to like build the inputs and build the outputs,
yes,
and
yes.
like
For
you need to
now,
do
it's
all
just
this
one
stuff.
of these guys, so we can just use this syntax. But
Yeah.
if we have to change multiple things in this, this might get a little overbearing. So we can just like define them up here, like say, let transaction dot placeholder dot something is equal to this. Like,
Yeah.
we actually assign each of the parts of the transaction. So we basically assign each part of this as necessary. We define the inputs, we define the reference inputs, all of those
Hmm.
guys.
Hmm.
Okay. I think I understand this.
Yeah, I feel good.
Okay. And similarly, I think this is also pretty straightforward. In this passes because the message is exactly the same, and also the signatory part, the signature part, matches exactly with the owner part. So the whole thing passes, and those are the only two things we are considering here, and both of them have passed. Here, the message is wrong, so immediately it fails, and also we're not passing the signatories, so this will fail anyway because
But
everything is wrong.
that test is actually succeeding because when we write failure tests, what we do is we prefix the name of the test however you want, but here we have test fail, hello world. And then what you do on line 75, you can see we add the exclamation mark.
Yeah. So in this, even if I do this, it'll fail because our message is wrong in this case. Although we have the correct datum owner or the signature, correct signature, it still fails.
Yeah, I guess the point I wanted to highlight was this right here is like when we have a failure test,
Hmm.
we do this this exclamation mark here in front of the action, and this is
Really?
saying the opposite. So what we want is we want this hello world to fail, and when it fails, we get the opposite, which turns true. So then this test
S-
succeeds by failing.
No, I think this test still. Oh, wait a minute. No,
No
I
fail
think
because
I
it
think I
does.
think this the fail part here in the name itself serves as the exclamation without having the exclamation is what I think.
Well, but you want a green success. You don't. That's going to be a red fail.
Oh, really?
Yeah,
Oh, I thought.
right. We don't want any of those fails.
Oh, so we need to make sure that this. Okay, that makes sense.
Yeah, because we want it to fail. That's a success.
Oh, wait a minute. It actually succeeded. Look here. So this is the second test and it was a pass.
Uh,
See, fail hello world example 2 is a pass. And
okay, because must say hello is false. Wait,
so
do
let me try it one more time because
yeah,
I'm not sure. So, oh, it is a fail. You're right.
yeah,
You're right. You need the exclamation mark, right? You need the
yeah.
exclamation. So this is the wrong message. Yeah, you do need the exclamation mark here.
Because the
Oh,
goal is the successful test. And when it's failing when we want it to fail, that's a success.
correct.
Because like often that's what we're doing. It's like it can work in one way, but it needs to fail in all of these other ways.
Correct.
And so you write these tests to figure out all of these fail cases and ensure that it is behaving how you want. So yeah, we want those green successes, and the way to do that is that exclamation mark in front of the action of spend, and then a
Hmm.
good convention is to label that test with fail,
Yep.
so you know.
Yep. Yeah, makes sense. So when you say fail, it is expecting this part to fail. And if this doesn't fail, wait a minute,
Then the test would fail.
then the test would fail.
Yeah, and we would get that red all caps failure in our
So
ink and
so
check.
here is why I'm confused. So this part without the exclamation fails. Right? Yeah,
Yep.
yeah, yeah. I mean, you're
Yep.
right. Yeah, fail
So
plus
yeah, so
fail
that's a
is
Boolean, right? So what's the opposite of
opposite of
fail?
fail is like
It succeeds.
pass. Yes, yes,
Yeah.
yes, yes. Makes sense. Makes sense. Okay, that made sense. This is a failure case. This is the same as this without the failing part and the exclamation here. So this will fail naturally. And we have the example. Oh, let me do this one more time.
Do a specific one too, so we can show that
Okay,
instead of
so
all of them. Yeah.
yeah, so if you want
Dash.
to only check one specific test, all you have to do is A can check with the flag M, and then you say, for example, you want this test. You just do this. You just copy the name of the test and paste it. And then the exact specific test that you want to see like shows up, which
Yeah.
is this one.
So that failed because must be signed is false.
Correct.
So let's fix
So
that one.
yeah, so this is basically pattern matching with the name right here. When you use the flag M, it pattern matches with the name of the test.
Right. So you could just do a can check dash M 3, and that one should show up because 3 is pattern matched in the name.
Correct. So let's try that. So instead of the whole thing, I'll just write 3 and then it should show up. Yeah. So
Yeah.
this one shows up because this is the only test with the name 3 in it. And by the way, when you are doing the Aiken check, it's actually checking all of the validators,
Yeah.
by the way. All of the validators. It's checking marketplace, it's checking vesting. So everything in the validators uh, folder, it'll be checking. Make sense?
Yeah.
Okay. And this last one is where we have everything right. We have the exact signatories and we have the exact message. And so this last one passes. I think we are good with this validator. I think I understand everything about this validator, including the tests, when they pass, when they fail, and when and how can I write a failing test, um, and how to define the types, and all of this. I think I pretty much understand this validator.